So now we're going to start talking about structural design patterns. Now, structural design patterns are concerned with how objects are made up, or what the composition of objects are, and how to simplify relationships between objects. Now, if you remember back in Module 1, I said that design patterns are all about relationships. And in creational design patterns, we didn't see a lot of relationships because we're interested in creating an instance of an object. The only one that dealt with relationships really was the factory pattern, where it was creating other objects. Well, in structural patterns, it's all relationships. It's all going to be about, let's take one object and how this new object relates to something else. Now, structural patterns, like I said, deal with the relationship of an object, and they do it in two ways. And the ones we're going to look at will either extend functionality or simplify functionality. So I've got two extremes here. We're going to talk about the decorator pattern, which is going to extend the functionality of an object. We're also going to talk about the flyweight pattern and the facade pattern, which are going to help simplify functionality, or at least mimic simplifying functionality, to make things easier to use. So it's all going to be about how one object relates to a separate object. So the first pattern we're going to look at is the decorator pattern. And this pattern is used to add new functionality to an existing object without being obtrusive. And there's a couple different levels to this that we're going to look at. We're going to look at simple, just adding new features to an existing object, and then we'll look at true subclassing and how that works in JavaScript. Now, one of the things we're going to talk about here is more complete inheritance, so how I can actually fully inherit an object in JavaScript, which is a little bit different than how you would do it in .NET or Java. We're not going to only do that, but that's one of the things we're going to look at. The decorator pattern wraps an object. So you could take an object, like task in our case, is what we've been working with. Object already works, and so I want to protect the existing object because it's there and it's used everywhere in our application. I want to add some functionality, or I want to wrap that functionality with some additional features that weren't there before without having to change task itself. And so what we're going to look at is we're going to look at a couple of different ways to add what we would call an urgent task. So something with a notify method or a deadline or something like that, so that we can create a new decorated task that's not going to change the way task works itself. All right, so let's take a look at just some simple decoration to see some options that are available to us without a whole lot of effort. So here we've got a task constructor, and basically all it does is create a name and completed. This is the same task we've been using kind of all along if you're following along. It's got two methods, complete and save, and those things do things right now. And what you'll see is that we're creating a task and we're completing it and saving it. So when I run this, you're going to see, I'll just run it again, completing task, my legacy task, and saving task, my legacy task. Now, the problem that the decorator pattern is trying to solve is I don't want to mess with task because my task is working. And I don't want to take a chance of implementing some bugs into my task when I'm trying to create something new. And so what we're going to create, and I'll fold some of this stuff up, is we're going to create an urgent task. And so we'll do var urgent task equals a new task. And we'll just do the same thing on all of this. Instead of legacy task, now we're going to be urgent task. So now I've got an urgent task and a legacy task. But what I can do, and one of the cool things about JavaScript, you don't get to do this other places, is I can just start changing stuff about this object. So I can say urgent task dot priority equals 2. And I can even create a new method on this. So I can do urgent task dot notify and make that a function. And say notify is going to just write out to the console right now, but I could say, hey, I'm notifying important people. And so then my urgent task can now notify. And so if we run our code, you'll see I'm completing my legacy task, but now I'm notifying important people and completing my urgent task stuff as well. So I have decorated urgent task with a priority and a new function called notify. And that's great, but I can even take it a step further and I can add notify to my save. So I can say urgenttask.save equals a function. And I can do this.notify, and then I can do task.prototype.save, and we can use .call. And what .call is going to allow me to do is use the this keyword and bind the save execution to the this scope. So now I've overridden urgent task with save, so that now I'm going to notify, and I'll get rid of this notify so that we can see it working. And then I'm executing the save as well. And so now I'm going to do urgent task.save. And what you'll see when I run this is now we're saving task, urgent task, and there's our notifying important people. So when I do urgent task.save, I have decorated urgent task with a new save. And I'm notifying important people, but then I am also calling the save, the original save, off the task prototype. So this is simple decoration. I'm taking a task and I'm decorating it with some additional features and functionality so that I don't break the existing task object. Now let's do something a little bit more complicated, because I created urgent task and that was great, but if I want more than one urgent task, I don't want to have to do all that work again. And so if you look at the way our task was, every time I create a new urgent task, I have to go through and add the priority and add the notify again, and that's painful. So what we really want is more true subclassing, or since JavaScript doesn't have subclasses, we're going to call it sub-objecting. Even though that's not really a word, we're going to use it for right now, because I want to create a new object that wraps that task and allows me to decorate it with my notify and my priority and all that without changing tasks. So let's pop over to task. Actually, we'll just copy all this over to a new file. So I've got my task back. But now what we're going to do is we are going to create a subclass or a sub-object, no classes. We're going to create a sub-object that's going to wrap task in its own thing so I can create more than one of them. And the way we're going to do that is by creating a new constructor. We're going to do var urgent task equals, and we're going to have a name, but also pass in that priority. So if you remember, we wanted to add priority, so we're going to add that. And in .NET anyway, you would call super to execute the super class. In this case, we're going to use that call keyword again, and we're going to call the constructor of task to go ahead and execute everything there. And so if you remember, task would say this.name equals name, this.complete equals false. So when I do a task.call, I'm going to pass in this and then send name. And then I'm going to do this.priority equals priority. Now, if I create a new urgent task with, let's say, this is urgent and a priority of 1, when I print that out, urgent task should have 3 things on it. It should have a name and completed from task, but then it should also have priority from our urgent task constructor. So now, if we do our sub-objecting, you'll notice our urgent task has a name, this is urgent, completed is false, and a priority is 1. So I have a true sub-object from task. Now, I don't have everything, and that's a problem, because I don't have the prototype. I can't do ut.complete like I can with my task.complete because I don't have that prototype. So I have to add that. And so the way we do that is we use object.create. So I can do urgent task. We'll come up here. Urgent task.prototype. I could just set it equal to task.prototype. But the reason why I don't want to do that is because that just assigns them to each other. So if I start changing urgent task.prototype, it's going to start changing task.prototype too. And I don't want to do that. So what we're going to do is we're going to use object.create, and we're going to pass in our task.prototype. And what that's going to do is make a new object for my prototype out of tasks prototype. So those are different, and I'll show you that they're different here in just a little bit. But for right now, let's see if I can complete my urgent task. So now when I run my sub object, I see completing task, this is urgent. So now I have a true subobject. I've got a true inheritance going on where I have my constructor and I have my prototype all coming down to this new object, urgent task. But now I want to change some things. Remember over on the task before, we were changing save to do something. And we're going to do that again in this subobject because now I can do urgent task.prototype.notify and have that equal the same function. So I can just copy everything over from before, but now it's actually on the prototype of urgent task. And I can also do the save. I can do urgent task.prototype.save, and we can do some special stuff before saving, and then do that same task.prototype.save, and we use the call, like we did over here in task, where we added save.call this. I can do the same thing here, task.prototype.save.call, with this, and now this refers back to urgent task or whatever that object scope is that's there. So now when I do a ut.save, let's add notify in here too. So we can do this.notify. I can do this.notify, do some extra special stuff, and then save it all through here. So let's run that. Now look what we've got. We've still got our legacy task stuff. Nothing's changed on my task. Legacy task is still working, and that's the beauty of the decorator pattern, is because I don't want to mess with task, and I have zero risk that task is going to break. But now I have completing task, this is urgent, I'm notifying people, I'm doing some more special stuff before saving, and then saving the task exactly the same way that task is saving. I'm calling this same method, task.prototype.save, so I haven't changed anything. I've just wrapped it with some additional stuff. So this is more true sub-objecting and true inheritance that we have going on inside this more extensive decorator pattern. But you've got two options here. We've got very simple decorators in the task.js, where we're just adding a couple of properties and methods onto a new instance of task, or we're truly inheriting and creating a whole new thing called urgent task that I can create multiple versions of. So that's the decorator pattern in a couple of different forms. Let's see how decorators work over on the Angular side. Now let's start looking at how to do the same decorating things in Angular. And there's two different ways we're going to look at this. We're going to look at decorating objects in Angular, which will be fairly similar to what we just did in Node, but we're also going to look at decorating services in Angular using the decorator method that Angular provides for us. So first and foremost, let's do this urgent task over on the Angular side. Now here we are in our plunk, same plunk we've been using all along, and I've got my task manager, task 1, task 2, and if I open up developer tools and open up the console, you can see we're writing some stuff out to the console every time we do something. So completing task 1, completing task 2. Now what I want to do, we've got our task, is I want to create urgent tasks. I want to do the same thing. I want to be able to say urgent task, leave these first two as tasks, but then create urgent tasks as well. So I want to be able to have task 3 and task 4 be urgent tasks, while task 1 and task 2 are tasks. But the same save, the same complete and same save functions, this completing task and the save to the repository, need to stay intact because I don't want to break anything that exists. So what we're going to do is we're going to create a new file called urgent task. And when we do anything in Angular, we're always going to do our ifs. So I'm going to do function and then all of our curly braces and parentheses. And now we're going to actually create this urgent task. All right, so we're going to start by pulling in app angular.module task manager. And then we're going to do app.factory. And actually, if I pop over to task, the way we do this app.factory task and all of that, let's just copy that. So we're not typing everything over again. Now that's not ideally what we want, right? So we want to not have to replace everything. So we're going to do urgent task. And our urgent task constructor is going to be the same as what it was actually over on the node side. So let's actually do that. From this point, I'm just going to copy everything. So we've got task.call, our task.call, adding things to prototypes, the this.notify, the task.prototype.save, all of that stuff is going to work just fine. Let's just do this. Paste that there, beautify it all. We'll minimize this. And then we're going to return urgent task. So notice I haven't changed the complete function. The complete function from task is still going to be the same. So completing task, when you see that, that's coming out of task. I'm still calling tasks save, which really just calls our repo. But now when I run this, I'm going to have 2 urgent tasks and 2 regular tasks. One thing we still have to do though is add urgent task to our index.html. Spelled correctly. There we go. Now we missed one thing, so let's look at what's in our developer tools here real quick. Task is not defined. That's right. So in urgent task, we're pulling in task repository. We also have to remember to pull in task. So let's refresh that. Oh, and the last thing, when we copied it over, there's a couple things we got to do. In Angular, we were data. So let's fix that. Data.priority. And then we're passing data into our call. We just did it a little differently on the Angular side than we did on the Node side. So now we'll refresh. There you go. So if I clear everything out, when I click task 1 is just a regular task. So I'm going to get completing task 1, and then saving task 1 to the database. When I click on task 2, those are both just regular tasks. So completing task and saving task. When I click on task 3 is an urgent task, which means that when I complete task 3, nothing's going to happen. Nothing's going to be different. It's just going to work the same way as task. If you look in urgent task, notice there's no complete here. So when I click on complete for task 3, it's calling tasks complete that it pulled out of task.prototype. But when I click on task 3, the save is going to say notifying important people, doing special stuff, and then saving task 3 to the database, called 7 times. So there you go. Completing task 3, that came out of task. Notifying important people, doing special stuff, saving task 3. All of that stuff came out of the urgent task. So for this piece anyway, there's not a whole lot different between Angular and what we did on the Node side. All we did was create a new urgent task and pulled in task and wrapped it up with all this other stuff. So the decorator for an object works pretty much the same on the Angular side as it does on the Node side. One thing we're going to do in addition to this is we're going to decorate a service and see how that works differently using Angular's decorator method. So now let's look at how to decorate services in Angular by taking a look at our task repo and wrapping some logging around our task repository so that we can see how that works. So still in our plunk that we've been using this whole time, let's look at our task repository for just a minute. Now, our task repository is just a service that has a couple methods on it, get and save, that will handle database stuff for us. And if you're doing any size Angular application, you probably have several of these services that just kind of work. They do their thing and you don't really want to mess with them. But let's say in this case, I want to add a level of logging to my task repo, or maybe some auditing or some additional functionality, but I know this works and I don't want to start pulling apart this service. I want to wrap my additional functionality around this service that exists. And Angular actually has this built in, which is really kind of awesome. So all we have to do is use the decorator method that's attached to the module. And so let's create a new file and we'll call this repo decorator. So the same thing we always do, let's do our ify and let's pull in our app. So app equals angular.module and we're pulling in task manager. Now I want to wrap task repo. And so what we're going to do is decorate task repo. So angular.module actually has a method called decorator. And I can say I want to decorate task repository. If you look at the bottom here, we're putting out task repository. So I want to decorate task repository with something new. So basically all task repository was is a function, so I'm going to replace task repository with a new function. And I just used the word replace instead of decorate, and so we need to be careful of how that works and make sure we're doing it right so we don't break a whole bunch of stuff. But here's how this works. Angular is going to hand you the original service, and it's going to call that delegate. And so I now have the original service passed into my function. And if I just do a return delegate, I have effectively done nothing. I have just handed back to Angular what it handed me, and task repository at this point is unchanged. And it's especially unchanged because I'm not using this yet. So let's do that. Let's add this to my index.html and put it in there. Now, one thing that is really actually important here, usually in Angular, the order of these scripts doesn't matter. In this case, it actually does. We need to have our repo decorator underneath our task repo. All right, so now all that's there, and what you'll see, not surprising, is that absolutely nothing has changed, which is exactly what you would have expected. So let's keep going. All right, now what I want to do is I want to change the save method. I want to say delegate.save, and it's passing in a task equals function, passing in a task, and I want it to do some extra stuff. Now we're going to do some extra special logging for task with our task.name. Now, once I've done that special logging, I actually want to call the original save method from our old task repo, but I just overwrote it. And that's how that works. So now I need to get back to the old save method. And JavaScript closures are going to help us out here quite a bit because I can do this. Old save equals delegate.save. So I can save the old version of this function. And then once I've done my special logging, I can execute that old save. And even though this function is being executed out somewhere else, JavaScript closures say, hey, I still know what this old save is. So I still have access to this old save, and I'm going to pass this task in. Now, when I refresh everything, assuming I didn't break stuff, and I didn't, when I click task 1, it's going to complete it and it's going to save it. And when I save, it's going to say saving task 1 to the database, but it's also going to give me this console.log special logging for task. So when I click task 1, now you see I've completed task 1, and I now have special logging for task 1. And then it went ahead and ran the old save. So what Angular's letting me do here is take any service, and wrap that in whatever way I want to wrap it in. So I'm not having to pull apart the task repository to add a piece of functionality, or I could do notifications, or I could do auditing, I could do whatever I wanted to do here, and then call back to the old method and know that I'm not breaking a whole bunch of stuff. Task 1 through task 4 are all still working. If I click task 4, that's still working. Special logging for task 4 worked along with all the other urgent task stuff. So that's how the app decorator method works inside Angular to allow us to wrap services in Angular. The next pattern we're going to talk about is the facade pattern. And this pattern is used to provide a simplified interface to a potentially complicated subsystem. We've all dealt with APIs or classes or things before that just were nasty and very, very painful to deal with. The facade pattern gives us a way to stick something in front of that and make it very simple and easy for us to interact with that system. Now, when you think about a facade, usually you think about the front of a building. And when you look at a building or a house, when you're walking down the street, all you see is a very nice, clean front wall to a building. And there could be absolute, utter chaos going on inside that building or that house. But there's no way for you to know because all you see is a very nice, clean exterior interface to the building. And that's what a facade does, is a facade hides all that chaos from us, or the complexity of the back-end subsystem, from us so that all we have is a simplified interface to deal with when we're using an API or this application. Think about Jquery. Jquery is probably the most well-known implementation of a facade pattern. At its core, all Jquery does is sit on top of the DOM and give you a simple, clean interface to interacting with the DOM instead of having to do all of the nasty JavaScript you might have to do to change the name of a button or the class of something. Jquery gives us a nice, clean, simple interface to deal with the DOM when we're trying to manipulate our web page. Now let's take a look at the facade pattern in practice over on the Node side. So real quick, as these demos and as the patterns start to get more complicated, I'm going to try and pull some of that complication out and keep just the essence of the pattern so that we don't lose what we're trying to accomplish with the pattern in a whole bunch of implementations. So I'm going to, for this one anyway, keep everything in the same file just so we can refer back to everything. If you want to see, or you're still curious about pulling things apart and having different objects and services in different files, go back and watch Module 3 if you didn't watch Module 3, and I do a lot of that over there. In the facade pattern anyway, I'm going to keep it simple so that we don't lose the idea of the facade in all of the implementation of having everything split out. So that being said, I've taken our task object that we've been using all along and I've changed it around to be just properties. So this.name, this.priority, this.user, this.completed, all of those things are right here in task. And because we don't always get to pick the things that we deal with, I've created this task service. And task service is not cool. This service has a series of functions that are in the module pattern, unfortunately, not the revealing module pattern. And it looks kind of gross and it's hard to see what's going on, but that's what we deal with, right? That's the whole point of what we're trying to deal with the facade pattern. So I've got these series of functions that allow me to interact with tasks, but I have to call them all individually and there's no overlapping. So what it looks like now when we're dealing with a new task, on line 27 I've newed up a task, and then when I want to complete a task, I actually have to call the task service and complete the task, and then if it actually completed, I have to call 3 methods in order to get it all done. And that's just the way that API works, and the API kind of stinks, and that's just what we've got to deal with. So what I want to do now is take that gross chaos of dealing with this API and all these one-off function calls I have to make, and if you've been doing this for very long, you've probably come across an API that you had to deal with or a service that you had to deal with that made you do some things that you didn't want to have to do. And it was gross and you just didn't want to do it. Well, that's kind of what I'm getting at with this task service. So what I want to do is I'm going to create a wrapper or a facade on top of this service to make it look better. Now, the difference between the facade pattern and the decorator pattern is I'm not adding functionality. The decorator pattern was actually adding and manipulating the functionality of the original task. In this case, I'm not adding anything. I'm just covering up and creating a better interface for exactly the same functionality. So that's the difference really between the facade pattern and the decorator pattern. So let's do that real quick and clean this up a little bit. So what we're going to do is we're going to create a wrapper. And we're just going to call it task service wrapper. And all task service wrapper is going to be is just a module. So if you remember from module 3, the module pattern just is a function that returns an object, and that object consists of things. And that's actually what our task service is a module. And just a minute ago, I said that our task service isn't even using the revealing module pattern. It makes it kind of ugly to look at. Well, let's build our task service wrapper properly so that we're doing it right. And what we want to do is, if you look down here, we want to complete the task, and then we want to notify that it's been completed and then save. So what we're really going to do in our task service wrapper is we're going to create a function that does complete and notify. And we're actually going to create a function that's going to do that. And the revealing module pattern says that I'm just going to return something that looks like that so that I can see. Actually, we'll clean it up so it looks a little better. So I can see what methods are public and what's available out to the world. And now let's go create that function. So var complete and notify equals a function. And then we probably need to pass in task. And then I'm going to take all of this code that's in my main and put it in my wrapper. So now var complete and notify is going to call task service to complete, call task service to complete, and then if it's completed, it's going to set the complete date, notify of completion, and save. So I can now get rid of all this code down here and switch this over to task service wrapper dot complete and notify. Now, one thing that I'm doing here, and this is demo, but instead of now creating a new instance of this task service wrapper, and we're not creating instances, I know, but I'm just going to go ahead and execute this. So now task service wrapper is the return statement. So task service wrapper is now just an object that is complete and notified. Normally, if we're doing the full common.js pattern, it'd be in a different file, and this would be module.exports, and then I'd return the executed function, and that's essentially what I've done here. So now my task service wrapper complete and notify is going to execute, and everything will just work. And if we watch our console.log when I run this, you'll see all these three things have happened. We've set it a complete date, and we've saved, and we'll see a notification happen, notifying user of the completion of task. All that stuff will happen, but now I've got one line of code sitting in my main.js. So let's run that, node task.js, and there you go, completing my task. My task was completed on notifying John, and then you see completed is true, completed date is now. So that is the basic facade pattern. It's just that easy, complete and notify. We've just created a wrapper that wraps around our task service. And like I said before, we're not adding any functionality to task service. So that's the decorator pattern. Here we're just maintaining the same functionality, but we're just doing it in a clean way instead of having this chaos that we had before up in our task service. Now let's look at the facade pattern over in Angular. Now I've taken everything we just had on the node side and dropped it into a plunk in Angular. So to look at it, we've got our task.js, which now is just a series of properties. There's no methods or anything, nothing on the prototype like we used to have. It's just like this. I have a task repo, which is the task service, which is this ugly, nasty looking service that we had over on the node side. It's got a bunch of complete, set complete, notify, all that stuff that's on here. And then we have in our script.js, I'm creating a new task with all of these things. And then when you check this checkbox, it's going to do the same thing we were doing before. So complete task, when you check the checkbox, it calls complete task and it passes in the index. If you look at index.html, there we go. Ngclick controller.complete $index. And it's going to do this same thing. It's going to complete it. If it's completed, it's going to set the complete date, notify completion, task.save, all of that stuff. And it's gross, and we don't like it. But you know what? It works. When I click the checkbox, there you go. Everything works. So let's build a facade over top of our task repo and fix that. So we're going to create a new file called task service facade. Now you wouldn't in production necessarily call this a facade. You'd either call it you could call it a wrapper, or you can just call it whatever makes sense for your application. I'm explicitly calling it facade just because that's the pattern that we're talking about. All right, so in our task service facade, do our iffy. Now I haven't talked about this up till now, but there's some discussion over whether we put that second here or in here. I like to put it inside like this, because when I'm teaching classes or I'm training people, I can say make a little face. So you've got an eyeball, a nose, an eyeball. And that way, it's just an easy way to say, hey, if something's not working, make sure you've got your face going on. So this is the way I do my iffies. It's not It's not the way everybody does it, but that's either way it will work. Now, inside our iffy, we are going to pretty much do the same thing we do over here on our service, right? We're going to create, well, first of all, we got to pull in our app. So var app equals Angular.module task manager. And then we're going to create a function. Task service facade equals a function. And then we're going to export that. Well, not export it, but we're going to do an app.service equals, not equals, because we know that won't be good. Task service facade. All right, now inside this function, we're going to take exactly what we had over on the node side. You know, this task wrapper, or we called it a task wrapper on the node side, this task service facade is just going to be one function, complete and notify, that's going to do some stuff. Now we've got to pull in our task repo. Now task repo is task service, all lowercase like that. So we're going to tell Angular, hey, I need task service. And then since it's differently cased, we got to paste some stuff in there. Okay. Now that's the wrapper. It's the same as it was over on the node side. Basically, we've just built a method called complete and notify that takes a task and then does the stuff that we want done on the task service. And then we return, using the revealing module pattern, that function. Now in script.js, we're going to copy this because in script.js, we need this passed in. So I'm going to just add it for right now. Ideally, we would be replacing it with task service, but you're not always going to replace all of the functionality of task service. In an ideal world, you would, but you can't always do that. So in this case, I'm just going to add my task service facade. And then instead of all this code, we're just going to delete all that and do our complete and notify on this task that we pulled out. And it's task service wrapper dot complete and notify on my task. So what we should see is this same thing happen again, but now with just this one line of code. So before I get carried away, though, we do need to add this JavaScript file, copy that into our index.html. That's going to be important. All right, now let's refresh, hit my task, and there we go. Completing task, my task completed. Everything's done, but I got all of that junk out of this function by wrapping my task service with this facade. So that's the facade pattern. There's no magic here. It might seem even a little simplistic. Yes, we're just taking code out of one place and we're putting in someplace else. And we might add a little bit more to it, but remember, the goal here isn't to add functionality. The goal is to mask chaos. And that's what we're doing here, is we're taking all those function calls we had to do in order to interact with that one service, and we're hiding them inside a facade so that it simplifies our controller. And really, if we're talking best practices, you want to keep your controllers and your business logic separated out and keep your controller code as small as you can, just so that it's easier to read and much more maintainable. So the more you can pull things out and hide grossness with some facades, the more maintainable your code's going to be. The last structural pattern we're going to talk about is the Flyweight pattern. And the Flyweight pattern is used to conserve memory by taking portions of an object and sharing that across objects. So think about it this way. Our tasks have a lot of non-unique data. If you look at all the tasks that we might put together in our task management program, there's only a small number of users. There's probably a small number of projects. If we had priority, there's only a few options for priority. And yet we replicate that data. So if I have 5,000 tasks, which over the course of a year is probably fairly easy to get to, if I had 5,000 tasks, that string, John, is going to be shared and replicated 5,000 times, because all of the tasks that I work on, usually it's me working on them. So I've replicated that one string 5,000 times. And so what flyweights do for us is they share data across objects. So instead of replicating that name, John, 5,000 times, my flyweight pattern allows me to share that across all the objects, so I only do it once. Kind of like when we were doing the object prototype, instead of creating the functions a whole bunch of times for every task, we add them to the prototype. Well, Flyweight's going to let me do kind of the same thing, but in a slightly different way. The overall result is a smaller memory footprint. Now, on the browser, sometimes memory is not as important as we would like it to be, and especially once it comes down to the mobile device. You want to keep your memory footprint as small as possible, and in some cases, the Flyweight pattern is going to help us reduce that memory footprint. And so think about it, it's like a boxer, a flyweight, the smallest possible thing that you can get, that's what we want to get. But this is only useful. So this is the big caveat to the Flyweight pattern. It's only useful if you have large numbers of objects. If you've got 100, 500 objects, implementing the Flyweight pattern, unless your objects are really large, is not going to do you a lot of good because there's some overhead to implementing the Flyweight pattern. So when I say a lot of objects, I mean a lot of objects. And we'll look at what that looks like when we do our demos. All right, let's look at the Flyweight demo, and this will start to make a little bit more sense. Now, because of the complexity of the Flyweight pattern, the setup for this demo is going to be a little bit more complicated. So let's take a minute and walk through what we've got going on so that when I start making changes, everything will make more sense. So to start with, right here, we have our task object. Now, our task object looks a little bit differently now, because I'm adding some more things to it. We've got a name, we've got priority, project, user, and whether or not it's completed. There's more pieces of information on our task object. Then I've also gone a little bit deeper and actually made a task collection. So what this collection is going to do for us is I've got 3 methods, and you know that because I'm using the revealing module pattern, which says I've got an add, a get, and a get count. And what those 3 methods do, the add method adds a task to the collection. It actually will new up a task based upon some data and then add it to my tasks collection, which is really just an object. And the key is my name, the name of my task. And then get is going to go pull it back out. And then my get count I'm using just so that we can do some metrics later. So now what we're doing is I've created an array of the different types of projects. So a task can have no projects. It can have courses, it could be training, or it can be a project. So these are the different types of things that I work on a given day. I'm either working on a course, I'm doing some training, or I've got some project work going on. Priorities 1 through 5. And I've got a set of users of people I might be assigning tasks to. So these are others. So it's me, Erica, Amanda, Nathan. These are people I might assign tasks to. So the user on a task, and then completed is either true or false. And I've created in this for loop just a loop that's going to create random tasks. So I'm going to create 10,000 random tasks so that we can see what the impact is of what we're doing. I'm able to, using process.memory usage, to see how much memory we're actually using in our application. So I can do process.memory usage and get the current memory that's being used by our application. I'm pulling in the initial memory usage. Then I'm going to create 10,000 objects. And then once those 10,000 objects are created, I'm going to pull in my after memory. So we can see how much memory I've used over the course of creating 10,000 objects. And then I'm going to write out to the console how much memory we've used. It's in bytes, so let's do megabytes. And then console log, tasks, and just how many tasks we've created. So if we run this, just by doing node main.js, what you see is we've used 3 megabytes of data and we've created 10,000 tasks. If I change this to 100,000 tasks and run it again, now we've used 28 megabytes, which I've multiplied it by 10. That kind of makes sense, and created 100,000 tasks. Now let's implement the Flyweight pattern on this so that we can see what impact that would have on our memory usage as we go. Now remember, I said this is only used for things that are fairly complicated, and what you might see is that when we add the overhead of the Flyweight, this initial memory might go up a little bit, and the reason is I'm having very simple tasks. It's basically just a set of strings. When things get more complicated, that's when the flyweight pattern starts to make a little bit more sense. But let's run through creating a flyweight so you can see kind of how this thing works. So let's minimize our task collection here because we're not really worried about that anymore. And let's create a Flyweight Factory. Now, really, you can call this something else like subtask or, partial task or whatever you want to call it. But I'm going to be explicit, and I'm actually going to call it a Flyweight Factory. And this is going to be a function. And realistically, we're just going to immediately execute it. So put our face in there because we want the Flyway Factory to actually be the factory itself. And the Flyway Factory is going to do two things. It's going to create a new flyweight and it's going to return a flyweight. And then we also want to put a count on it, just like we had before. So let's start by setting up our collection object. Just the same way we did in our task collection. See, we've got our var tasks there, so we'll do our var flyweights. And then we're going to ask for a flyweight. Now, a flyweight is a subset of a task for us. So if you look at the task object, the only thing that's unique, 100% unique for a task, is this .name. Everything else is shared across one or more tasks. And we know that because down here, I'm creating random values for the rest of these things. So the only thing that's unique is the name. So everything else can become part of a flyweight. And so what we're going to do is we're going to create a get function that's going to be responsible for getting a flyweight for us. And this get function is going to take all of the things that are not unique to the task. So in our case, it's the project, the priority, the user, and completed. So I'm going to pass those things in to my Flyweight Factory. And then my Flyweight Factory is going to check and see if that exists in its collection of flyweights. And if it does exist, it's going to return it. If it doesn't exist, it's going to create a new one. So right here, if not flyweight, if this collection of project, priority, user, and completed does not exist already in our flyweight collection, then we're going to create a new flyweight using those four things. And basically all that flyweight is, and we haven't created that yet, all that flyweight is those four things. So let's create that real quick. So now we've got a flyweight object that takes project, priority, user, and completed and just does this dot on them. And basically we took this dots and we moved them down. So I'm actually going to comment these out. There we go. Now, if that flyweight already exists, it's going to return the flyweight that exists already. So now what we need up here in our task is to add the flyweight. So we've removed priority, project, user, and completed, and we've added a flyweight. And basically we're just saying, hey, Flyway Factory, get me a flyweight with this project, priority, user, and completed. If that flyweight exists, hand it to me. If it doesn't exist, create a new one. And that's what we're going to do. So the last thing we want to do on Flyweight Factory is implement a Getcount because we want to know how many flyweights there are. So basically, all we're doing is var Getcount is now a function that's going to count the flyweights. And then we're going to return an object in our revealing module pattern, our get and our get count. So up here we're using get flywayfactory.get, and then down here we're going to add a line for get count. So right now I'm logging the number of tasks. Now let's log the number of flyweights. Real quick, copy paste Flyway Factory. I didn't capitalize the W. Now let's do it. All right, now I've got 100,000 tasks, but only 160 flyweights, which means that data is shared, the priority, project, user, completed. Any combination of those things was only shared 160 times. So I've cut down the amount of memory that was used. Notice I was 28, now I'm 25, so not a huge amount, but I've cut it down. If this was maybe a little more complicated and we had more, it might be more. But right now, implementing the Flyweight pattern on just this simple task has saved me 3 megabytes of memory, which is pretty decent overall. If I add another 0 to this, notice I'm up to 279 megabytes of data used. And if I drop my flyweight, and I go back to doing it the old way, I go from 279 megabytes used to 319 megabytes used, which on a percentage basis is actually fairly significant. So the idea of sharing pieces of a task, or an object, in this case, a task, across tasks to save myself extra memory can make at least somewhat of a difference. And it depends on the complication of your object. Now, one thing we didn't do, and we could go through the motions of it, is right now your interface has changed. Right now we've got a .flyweight something. And what you would do is you would add on the prototype for task .prototype let's say get priority, and you would return this .flyweight priority, so that you don't have to expose the fact that you're using a flyweight. You do everything with getters and setters, and the fact that you're using flyweights is not visible to you. All right, so that's the flyweight pattern. And I admit the flyweight pattern of the three we've looked at on the structural patterns is probably the least likely to be used, but when you need it, you need it. So if you're doing things with large data sets, or you have many instances of an object, the flyweight pattern might be a good way for you to cut down on your memory overhead to help improve your performance. So in this module, we were dealing with structural design patterns, or patterns that are intended to change or at least alter the view of an object. Creational design patterns we talked about first, that we're dealing with creating new instances of objects. In this case, the structural design patterns, we're dealing with altering the composition of objects. And we talked about the decorator pattern, which allowed us to add additional functionality onto an object without having to change that object itself. We looked at a couple different ways to do that, with either additional logging or adding new functionality to take a task to an urgent task. We looked at the facade pattern, and we looked at how to hide a lot of junk and a lot of maybe nasty API implementation behind a clean wrapper or a facade to give us a nice view of an API. And we ended with the flyweight pattern, which we talked about how to use that to create pieces of objects that can be shared across our object collection to help reduce our memory footprint if needed when we have large numbers of objects. So that's it for the first two types of design patterns. We've got one type left, and these are behavioral, which are going to be more about interactions between objects and how to communicate across objects.